Apache NiFi is an open-source data integration tool designed to automate the movement and transformation of data between systems. It's built by the Apache Software Foundation and is often used in data engineering, IoT, ETL, and real-time analytics pipelines. Use case and examples. It is used to automate the flow of data between systems. For example, FTP to Hadoop, Kafka to Elasticsearch, etc. It has a simple drag-and-drop interface. It is scalable across a cluster of machines. What Apache NiFi is good at? It is reliable and has a secure transfer of data between systems. Delivery of data from sources to analytic platforms is done with ease. Preparation of data can be done by conversion between formats, extraction or parsing. Tool demonstration. Data ingestion. Let's add two processes. PutFile and GetFile. Establish a connection between the processes. Configure the processes to edit the input directory and output directory for both the processes.
Edit the relationships to terminate after success or failure. Start both the processes.
Let's add few files in the input directory. You will notice that the files have vanished.
The files are actually transferred to the output directory.
Let's add few files in the input directory. You will notice that the files have vanished.
The files are actually transferred to the output directory. Data transformation.
Let me go ahead and add a GenerateFlowFile processor and configure it to generate random data every 5 seconds of size 1 byte. Next, let me go ahead and add another processor called ReplaceText processor. Go ahead and configure the processor and see how it works in practice. Let me establish the connection between GenerateFlowFile and ReplaceText first. Now that the connection is established, we will go ahead and view the configuration of the ReplaceText processor. To understand the usage of any property or the value of a property, you can use the information icon next to it. You can use this information to understand any processor and what are the various ways you can use the processor before designing your flow. A ReplaceText processor can be not only used to match a regular expression and replace the matched value with some alternate value, it can match any string literal and replace it with another value. Also, it can completely replace the content of the flow file with the replacement value without matching it with a regular expression or a string literal. Or it can be used to prepend or append your text to the flow file content. You can also see if you select a value of a property, it makes another property absolute, or the behavior of the property changes based on the value of another property. The next property is maximum buffer size property. This defines the maximum size of the flow file to be buffered before processing it. And if this limit exceeds, the flow file will go to the failure relationship path. The next property is the character set property, which helps to denote the processor on the character set the flow file is encoded with. The next property is search value property. This property takes a regular expression or a string literal which will be used to compare the flow file content and replace it with the value available in the replacement value property. Here, I want the ReplaceText to replace any content available in the flow file with a comma separated value, say ABCD. To do so, I will update the replacement strategy property to always replace and update the replacement value property to ABCD. That's it. To logically end this flow, as usual, I will add a LogAttribute processor and connect the ReplaceText processor with it. Before going on to the next step, let's go ahead and test this flow by starting the GenerateFlowFile processor first. As you can see, once the GenerateFlowFile processor is started, we got a flow file of 1 byte with a random character in it. This can be seen in the connection queue itself. You can validate the same by exploring the queue and view its content. Now, let's go ahead and start the ReplaceText property and see what happens. We got the flow file in the next queue, and now the content size is 10 bytes. This is due to the 1 byte random character is replaced with ABCD with the help of the ReplaceText processor. Let's confirm the same. As you can see here, the ReplaceText processor simply replaced the value of the flow file with the replacement value provided by us. Let's go ahead and add the next processor. The next processor I would like to add is the ExtractText processor. Using an ExtractText processor, you can extract out the value of the content inside the flow file into one or more flow file attributes. To extract a flow file content to an attribute, we can add a new property to the processor and assign a regular expression to it. Now, let me go ahead and add a new property using the add icon and assign its value to the following regular expression. Here, the regular expression used will extract, split, and assign the values of the flow file content into a flow file attribute called CSV. We can connect the ReplaceText processor with the ExtractText processor by dragging the existing connection between the ReplaceText processor and the LogAttribute processor to the newly added ExtractText processor. Also, let's create a new connection between the ExtractText processor and the LogAttribute processor for the matched relationship. For now, we no need to worry about the unmatched relationship, so we can auto-terminate the same. That's it, the flow is completed. We can test the ExtractText processor by starting the same and analyze the output flow file. As you can see here, now the size of the content is not changed. The reason for this is the ExtractText processor will only extract the content to attributes without altering the actual content. First, let's go ahead and take a look at the list of attributes. As you can see, we got new attributes here with the prefix CSV with the extracted out values. We can also confirm the content of the flow file is unaltered using the view content option.